In this video, I am going to teach how to solve predictive parser problem. Predictive parser is one kind of top-down parser. It is otherwise called recursive descent parser or LL parser. These steps are needed to solve predictive parser problem. First, we have to find whether the grammar having any left recursion are ambiguous. If it is there, we have to remove it. Then compute the first and follow. Then construct the parsing table. Finally, we should do the stack implementation using this parsing table. Let's see these steps one by one. In your examination, the grammar is given. In this example, I can take this grammar and one input string is given. We have to check whether this input string is valid for this grammar or not. First, I can check whether this grammar having any left recursion or ambiguous. The first production having the left recursion and also third production having the left recursion. By applying the left recursion, removing the formula for each production. After removing left recursion, we can get these productions. Apply the same rule for this second production also. So after that, I can rewrite this grammar. From this grammar only, I can find the first and follow. I can rewrite this grammar again, each line having the single production rule. The next step is to find the first and follow. You can find the first of all non-terminal present in this grammar. First, I list out the non-terminal like this. For capital E, the first element is capital T. Capital T is the non-terminal, so I am going to find the first of capital T. The first of capital T is first of capital F. The first of capital F is open bracket and ID. So I can write open bracket and ID as the first elements of capital E. First of E dash is plus and epsilon. Both are terminal only. So I can directly write the plus and epsilon here. Then first of T. First of T is first of F. So first of F is open bracket and ID. So I can add open bracket and ID as the first element of first of T. Then I am going to find the first of T dash. First of T dash is asterisk symbol and epsilon symbol. So both are terminal. So I can write asterisk and epsilon directly here. Then first of F is open bracket and ID. I can write open bracket and ID as the first of F. So the computation of first is over. The next step is computation of follow. So you need to compute the following element of all the non-terminal. So you can list out this non-terminal like this and you can find the follow of all non-terminals. For these non-terminals, capital E is the starting symbol. So I can add dollar symbol here. Then I can search capital E can be present in the right side of the production. So this rule having the capital E, the next following element is the follow element of capital E. So closed bracket is the another element that can be added as the follow of capital E. Capital E is not present in any other productions, so I can stop this operation. Next, follow of E dash. E dash can be present in these two rules only. So first I can take this E dash. There is no next element. So the follow of capital E can be copied into the follow of E dash. So dollar symbol and closed bracket symbol are added as the follow element of E dash. So this E dash is over. Next I am going to this E dash. There is no next element. So the follow of E dash can be copied into the follow of E dash. So already we are copy the dollar close bracket is there. So we need not to do anything. Then I am going to find follow of T. T can be present in these two rules only. So the following element is E dash. E dash is non-terminal. So I can find the first of E dash. First of E dash is plus and epsilon. So instead of E dash, I can put plus here. So the following element is plus. And if I substitute epsilon here, there is no element in the next element. So the root element of capital E can be copied into follow of T. So dollar and closed bracket can be copied here. And we can go to the next T. The next element is E dash. The first elements are plus and epsilon. Plus is already copied here. The next first element is epsilon. Epsilon means there is no element here. So follow of E dash can be copied into follow of T. In follow of E dash, dollar symbol and closed bracket is there. Already we are copied dollar and closed bracket from E. So we need not to copy again. So follow of T is over. Then follow of T dash. The T dash can be present in these two lines. So after t dash there is no element. So follow of t can be copied in follow of t dash. So all this plus dollar close bracket can be copied here. Then come to this next one. In t dash there is no element, this next element. So you can copy the follow of t dash into follow of t dash. So no need to do this again. Then follow of f. F can be present in these two lines. So after that t dash is there. So t dash first element is star. So I can add the star element here. Then another t dash first element is epsilon. If you substitute epsilon here, the next element is epsilon. That means there is no element. So follow of t can be copied into follow of f. So what are the elements follow of t? That is plus dollar close bracket. That can be copied in follow of f. F can be present in another production also. So T dash first can be we are already added and follow of elements also present in this F. So we need not to do anything. So this is the following elements of all the non-terminal present in this grammar. Next we are going to construct the parsing table. First you draw the two-dimensional table like this and you can list out what are the terminals and non-terminals available in this grammar. You can write all the non-terminals as row wise and you can write all the terminals available in this grammar in column wise. And finally you can add the dollar symbol. This is the initial stage of predictive parsing table. In this parsing table, each cell contains the any one of the production rule. So I can list out the grammar rule here. I cannot fill all these elements. Using the first element, I can fill these production rule and that particular cells only. So first of E is open bracket and ID. So I can select these two cells only. From these two cells, I can fill the production that can be started from capital E. There is only one rule is there. So I can fill E tends to TE dash in these two cells. So keep it in mind. You can fill the production rules here with the help of the first element. The first of E dash is plus and epsilon. So you can write the rule in the plus column. As well as epsilon is there. If epsilon present in the first, you can check the follow of E dash. In follow of E dash, dollar and closed symbols are there. So you can choose dollar as well as closed bracket also. Now you can only fill these three cells only. So for plus, you can write E tends to plus TE dash. For epsilon, you can choose these two cells. So write E tends to epsilon in these two cells. Then going to the third row, that is capital T. Capital T is only one rule is there. Check the first of capital T, open bracket and ID. So you can write T tends to FT dash in these two cells only. Then go to the T dash. T dash first is asterisk symbol as well as epsilon. So in asterisk symbol, then epsilon means you can go to the follow of T dash plus dollar closed bracket. You can also choose these cells also. So for this symbol, you can write T dash tends to asterisk FT dash. These three cells can be selected from this follow by means of epsilon symbol. So you can write T dash tends to epsilon in these three cells. Then final row is capital F. Capital F having two rules and first of F is open bracket and ID. So in this open bracket you can write this first rule and this ID you can write the second rule of capital F. So in this way you can fill the production rules available in the grammar with the help of first and follow. So constructing the parsing table step is over. Ensure each and every cell having the single production rule only. Then only we can go to the fifth step. If any cell having multiple production rules, we cannot do the stack implementation operation. The last step is stack implementation. In stack implementation, you can create three columns. First one is stack, second one is given input string, and third one is action. In this problem, the given input string is open bracket ID plus ID closed bracket. Starting symbol is capital E. So I can write the capital E after the dollar symbol. Then I can write the given input string followed by dollar symbol. So this is the initial condition to start the stack implementation process. Now you can compare E and open bracket in the parsing table. So E and open bracket, the rule is E tends to TE dash. You can write the E tends to TE dash as the action. Now you can replace the capital E by means of TE dash. When you write the TE dash in stack, you can write in reverse order because stack is the last in first out data structure. Then you can write the given input string as it is. Now you compare T and open bracket in this table. The rule present in T and open bracket is T tends to Ft dash. So you can write the T tends to Ft dash here. So instead of T, you can write the Ft dash in reverse order. So first you write the T dash, then you can write the F. Then compare F and open bracket. That is F tends to open bracket E closed bracket. Instead of F, you can write open bracket E closed bracket in reverse order. Then compare open bracket and open bracket. If both the elements are same, you can pop out from this stack as well as input string. So you can remove these two symbols and write the remaining items in stack as well as input string. Now you can compare E and ID. In this table, E and ID is E tends to TE dash. I can write this rule here. Then I can replace this E by means of TE dash in reverse order. So E dash into T. Compare T into ID in this table. T into ID is FT dash. So I can write T tends to FT dash. So instead of T, I can write FT dash in reverse order. Then compare F and ID. F and ID is F tends to ID. So I can write F tends to ID here. So instead of F, I can write ID. Then compare these two elements. These two elements are same means you can pop out from the stack as well as remove from the input string. So after removing, I can get the elements like this. Then I can compare T dash into plus in this parsing table. T dash and plus, that is epsilon. So in place of T dash, I can put epsilon. Epsilon means there is no element. So I can write like this. Then I compare E dash into plus in parsing table. E dash and plus, that is plus TE dash. I can write this rule, and instead of E dash, I can write these three elements in reverse order. Then I compare plus and plus, both the elements are same, so I can remove it. Now I can compare T and ID. T and ID is T tends to FT dash. So T tends to FT dash. So instead of T, I can write FT dash in reverse order. Then I compare F and ID. The rule is F and ID is F tends to ID. So instead of F, I can write ID. Then ID, both the elements are same. So I can remove it. The remaining elements are T dash and closed bracket. Check the T dash and closed bracket, that is epsilon symbol. So epsilon symbol means you can remove this element. Then E dash and closed bracket. E dash and closed bracket also having epsilon element. So instead of E dash, you can write epsilon here. Epsilon means there is no element. So you can remove it. Then closed bracket and closed bracket. Both are same element. So you can remove it. Then compare T dash into dollar. T dash into dollar is epsilon. So you can remove this T dash. Then E dash into dollar symbol. E dash into dollar symbol also epsilon symbol. So you can remove it. So finally you can get dollar symbol in the stack and as well as dollar symbol in the input string. If you reach this condition, you can write accept. It means this given input string is valid for this given grammar. You can write the separate sentence as an answer. This input string is valid for this given grammar. So in this way, you can solve the predictive parser problem. I can give the another example. You can do it yourself. This grammar is very simple. There is no left recursion and ambiguous in this grammar. So you can directly find the first and follow. This is the first and follow elements. After finding first and follow, you try to construct the parsing table. You can cross check your answer. And the given input string is CD dollar. You can cross check your answer with this line. This grammar having the left recursion in this line, you can remove it. After removing left recursion, you can get this the refined grammar like this. The next step is you are going to find the first and follow and construct the parsing table. You can cross check this answer. And the fourth one is you can find the first and follow and construct the parsing table. This grammar is somewhat different from other grammar because this grammar having the multiple entries in the single cell. When you encounter this kind of situation, you can tell that this grammar is not valid for LL grammar. So we need not do any stack implementation operation. In this example, the first of S dash having E and epsilon. For this E, you can add S dash tends to ES as the one of the production here. For this epsilon symbol, you are going to check the follow element. For this dollar symbol, you are adding S dash tends to epsilon here. For this E, you can also add S dash tends to epsilon in this E cell also. So In this way, you can get the multiple entries for this single cell. If the grammar having only one entry for the single cell means, then only the grammar is valid for predictive parsing problem. Otherwise, this grammar is not suitable for LL grammar or predictive parser grammar. So in your examination, such kind of grammars can also be given as a problem. So this problem can be asked in three different ways. A grammar is given, you are going to construct the predictive parsing table. So you can do the process up to the fourth step. In a second step, the grammar is given, also one input string is given. You need to check whether the input string is valid or not. So after completing these four steps, you also check the given input string through the stack implementation. In a third way, the grammar is given and you can check whether the grammar is valid predictive parser grammar or not, or valid LL grammar or not. So in this question, you are going to do all these four steps and check whether all the cells having single entry or multiple entry. If there is a multiple entry, you can tell the given grammar is not valid LL grammar. In the description part and download the solved problem as a PDF format.